This is the centripetal force trick. Centripetal force is not a separate force. Centripetal force occurs when we deal with circular motion, either uniform circular motion or non-uniform. For example, if a car is on a circular racetrack and is driving around, there is a centripetal force. Centripetal force is just whatever force pulls the object towards the center. In our last video, I talked about centripetal acceleration. So, to define centripetal force using what we have already learned or already covered, we have centripetal force is equal to mv squared over r. Now, if we can break this down, we can say centripetal force is equal to mv squared over r. And one thing we learned was that centripetal acceleration is v squared over r. So this is just m a c. So that is centripetal force. Centripetal force common examples can be tension, so it could be like a ball on a string with the swinging in a circle. So you have a ball on a string going in a circle. It could be gravity, right? When, say, the same ball is here going this way or going this way, you have a force pointing straight down, but it's still moving in a circle. You can have friction, as with this car example, and you can have normal force. These are all common forces that can kind of merge into centripetal force. So let's go ahead and get into an example. We have a 1,000-kilogram car turns in a circular path of a radius 40 meters at 20 meters per second. What is the centripetal force required for this to happen? So we know that our mass of the car is 1,000. We know its velocity is 20. And then we know radius r is 40 meters. So using the formula we found from above, F equals mv squared over r, we're just going to plug everything in. So this will be 1,000 times 20 squared over 40. And when we plug all of this in, we get that this is 10,000 newtons. So this does not mean that there are 10,000 newtons of force extra going towards the center. This just means that there is a force that's causing 10,000 newtons of force towards the center. So it's not an additional force, it is a force that already exists. So in this case, when the car is driving in a circle, we have, if we draw a free body diagram of the car, in this plane, we see that the friction force is pointing towards the center and normal force is pointing away. So in this case, your friction force is the same as your centripetal force because it's causing the car to go towards the center. And in my next video, I will do more problems, but this hopefully gave you a basic understanding of what centripetal force is, that it's not an additional force, it is a force that already exists. It's just any force that points towards the center. And with that, I'll see you next time.